Hey guys, how's it going? So I want to quickly go and do a quick lesson on what's called trig ratios of any angle over here. So example 1 says the point 4, -3 is on the terminal arm of angle theta in standard position. Determine the 3 trig ratios and the value of angle theta to the nearest degree. So what we want to do here is first thing we're going to do is we're going to quickly sketch the point 4, -3. So just draw your x and y axis here. 4, -3 would be 4 to the right and then 3 down over here. Okay, so here's our x-axis, here's our y-axis. This is the x-coordinate, this is the y-coordinate. Okay, so I'm just going to label this guy 4, -3. What I'm going to do next is draw a line to here and a line up like this. Okay, now the idea is like we always want to be able to make a triangle that has this vertical line going to the x-axis, wherever this axis is going to be, either this side or this side over here. And so this is our reference angle that we're using over here. Now, if I look at the legs of this triangle, this guy over here is going to be 4, and this guy is -3. Now, normally a triangle wouldn't have a length of -3, but since this is a negative y value, we are going to treat this guy as a negative. Okay. Now, the other thing I want to be able to do is I want to be able to go and figure out what the hypotenuse is going to be over here. Okay. Now, in this unit, I'm going to say in Math 30 as well, start doing trig. We start integrating circles into our trigonometry. Okay. So this is a very poorly drawn circle over here, but over here, if this is our point x comma y, like this, and then this one over here would actually be termed as the radius of the circle. Okay. Now, the formula we're using for that is going to be Pythagorean theorem, a squared plus b squared equals c squared, but in this case, it's going to be x squared plus y squared equals r squared. So in this question, we have 4 squared plus -3 squared equals r squared. This is 16 plus 9. This is 25. Square root, that means 5 equals r. Okay, so this is going to be equal to 5. Now, the rule we have is the x and the y values can be positive or negative depending on which quadrant you're in, but the radius is always going to be a positive value over here. Okay, all right. So now for this for here, this is my reference angle right here. Well, I'm just going to label my triangle. This is the opposite, this is the adjacent, and this is the radius or the hypotenuse. So in terms of, back to our grade 10 review here, in grade 10 we learned SOHCAHTOA. And another way of writing this is SOHCAHTOA, like this. Okay. Now what they're asking for is the 3 trig ratios. And this means sine theta, cos theta, and tan theta. So we need to figure out what those 3 guys are over here. So based on this, sine is opposite over hypotenuse. So we have sine theta is opposite -3 over 5. Cosine theta is adjacent over hypotenuse, which is 4 over 5. Tan theta is equal to opposite over adjacent is -3 over 4. Okay. All right. So here are 3 trig ratios. Now, last thing we're going to figure out the value of angle theta to the nearest degree. Now, my recommendation that you do is in this case we have 2 negative values and 1 positive value. My suggestion is use this guy over here. Now, other review from Math 10, if we have an equation like this, so cos theta equals 4 over 5, the way we can figure out what theta equals is by going cos inverse of 4 over 5. So I'm going to make sure that my calculator is in degree mode. I'm going to go second cos, so cos inverse of 4 divided by 5, and I get an answer of 37 degrees, because we're going to the nearest degree over here. Okay, so cos 37 degrees. Now, this is not my final answer, because this is my reference angle here, but we want to figure out what is my full angle theta, which would be this guy, based off the last lesson. This is the angle in standard position over here. So to do that, we're going to have theta is equal to 360 degrees, because one full circle is 360, minus this part, which is 37, which is 323 degrees, like that. All right, so there's the parts. My three trig ratios are here, here, and here, and my angle and center position is going to be 323 degrees. All right, very similar question, for example, to here. We have -9, 40 is on the terminal arm. So same question, just different numbers over here, okay? So step one, let's plot -9, -40. -9 to the left, 40 down. I'm just going to put a little like -9, comma, -40 here. Oops, that goes up there. And we want to draw a line with the x-axis. That means we're going to draw a line up over here. So guys, common mistake is people will try to draw a line here, but we always want to make that answer with the x-axis because our reference angle is going to be this guy right here. So there's our reference angle. All right, so this is -9 and this is -40. So to figure out the radius, we have x squared plus y squared equals r squared, or a squared, b squared, c squared. The Pythagorean, but this is our x coordinate, this is our y coordinate, this is our radius, or our r squared. So we have -9 squared plus -40 squared equals 81 plus 400 is 481, and the square root of 481 is not an exact value, so we're just going to leave this one as a square root of 481. Sorry, I made a mistake here, guys. Sorry, my mistake here, guys. My mistake was 40 squared is not 14. It's not 400. It is 1600. There we go. So that means this answer is 1681, and that means r squared equals 1681, and we're going to square root that. Square root of 1681 is 41. There we go. So r equals 41. So therefore, sine theta is opposite over hypotenuse is -40 over 41. Cosine theta is -9 over 41. And tan theta is opposite over adjacent, so it's -40 over -9. And since I'm dividing a negative by a negative, that becomes a positive 40 over 9 here. Again, guys, my recommendation, if I have two negatives and a positive, use the positive one. It's going to be easier to interpret your answer. So I'm going to go tan inverse of 40 over 9. That's my theta reference angle there. So I can go second tan 40 divided by 9, which is 77 degrees, 77.31961,651, but we're going to round to the nearest degrees, so it's 77 degrees. All right, so how do we figure out our angle and center position is going to be from here to here? Well, we know that from here to here is 180, and from here to here is 77. So it means theta is going to be 180 plus 77, which is 257 degrees. All right, example 3, we'll call special triangles. What we're going to do over here is we have two triangles we need to have memorized. Here's one of them. If I have a triangle like this, where one side is 1 and this side is 1 over here, well then this guy is going to be 1 squared plus 1 squared equals 1 plus 1 is 2. That means this is going to be the square root of 2. The angles that we have here are going to be 45 degrees and 45 degrees. Now, for this to work, if this side and this side are the same, I think you can see that this is going to be a 45-degree triangle right here. Okay. All right. So the reason why I do this is we draw a triangle with the angles, and we know this is 90 here, and these three side lengths. Okay. And what this tells us, we can figure out. Oops, this is not theta. This is now cos 45. And then we have sine 45, and we have tan of 45. we can figure out what we call exact values for these three ratios. Okay, so here, cos 45 is adjacent over hypotenuse is 1 divided by square root of 2. Sine 45 is the same thing. It is opposite over hypotenuse, which is 1 over root 2. Tan 45 is opposite over adjacent is 1 over 1, which just equals 1. Okay, so the thing, like I'm going to say that this is something that's necessary to memorize. I'm going to say memorize this triangle, and then from there you can figure out what your three trig ratios are going to be here. We have one more special triangle that we need to memorize. This is what I call the 30, 60, 90 triangle over here. So for this guy over here, it's going to start with a 1 and a 2. The hypotenuse is 2 and this guy is 1. And that means if I need to figure out this guy, well, this is Pythagoras, but I'm going to use the other way. I can go 2 squared minus 1 squared, which is 4 minus 1, which is 3. And that means this guy must be the square root of 3 over here. Okay, so this is another triangle that we need to have memorized. All right, so why is this useful for us? Okay, so these two, so this triangle and the triangle we had on the previous one helps us out with what we call our exact trig ratios. Okay, so what I want to figure out now is I can figure out sine 30 cos 30, tan 30, and I also want to figure out sine 60, cos 60, and tan 60. All right, so based on this, what's sine 30 degrees? So here's my 30 degrees. This is the opposite. This is the hypotenuse. The answer is 1/2. Cosine 30 is adjacent over hypotenuse, is root 3 over 2. Tan of 30 is opposite over adjacent, is 1 over square root of 3. Okay, so there's our three trig ratios for 30 degrees. Now I'm doing the same thing, and these guys are going to be very, very similar, but I'm going to do for 60 degrees. So if I'm doing sine 60, here's my angle, here's my opposite, here's my hypotenuse. It is root 3 over 2. Cosine 60 is 1 over 2. And tan 60 is root 3 over 1, which is just equal to root 3. Okay. Now, we use these to be able to figure out other types of problems. Okay, so for this guy over here, calculate each trig ratio, cosine of 210 degrees. So first of all, what we're going to do is we're going to sketch, well, what's 210 degrees look like? 210 degrees would be starting here. There's our initial arm. Here is 180, and then if we go down like this, that means we have a reference angle of 30. So this is 180, 30 for a total of 210 over here. Okay. All right. Now, reason why we did this is we have, if I have a 30 degrees, I know that this guy is 60 degrees here. Okay. Now, the triangle that we memorized on the last page was this guy, 30, 60, 90. It was 1, root 3, 2. Okay. Now, if I have cosine of 30 degrees, well, cosine is adjacent over hypotenuse. So we know that cos 30 equals root 3 over 2. Okay. So it's going to be the same thing for cosine of 210. Okay. So 210 is going to be root 3 here, 2 here, 1 here. Okay. Now, what's going to be slightly different here is, like we said before, is this that for this unit, and for, I can say, trig in general at this point, the x value, which is this guy, and the y value, this guy, are allowed to be negative, which is happening. If I'm going to the left of center this way and I'm going down, that means this is a negative value and this is a negative value over here. Okay, so what we're going to do is we're following the trig ratios off of this triangle over here, and this answer here is going to be the adjacent over the hypotenuse, which is negative root 3 over 2. Okay, trickier question over here, but we're using this special triangle in this situation here. We're being careful that this is a negative x value and a negative y value because I'm going to the left and I'm going down. The radius is always going to be positive here. But now I can figure out adjacent cosine, which is adjacent over hypotenuse, is negative root 3 over 2. Okay, tan of 300 degrees. So what's 300 degrees look like? Starts over here, here's 270. This is 300 degrees like this. That means I have a reference angle of 60 because I have a full circle's 360, and that means I have, so this is 300 plus 60 equals 360, okay? Now, very similar to what I did in the last question, okay? Well, this is my 30, 60, 90 triangle. Here's my 30. Based off that, this guy is 1, this is root 3, and this is a 2. Since I'm going down, I'm going to make sure this is a negative root 3 over here, okay? Using this reference angle, we have the opposite over adjacent equals negative root 3 over 1, which is negative root 3, okay? All right, sine of 225 degrees. Similar to what we were doing before, we're going to first sketch 225 degrees. That is 180, 270, 225 is down here, okay? Now, what I need to figure out here is what this reference angle is. Okay, now this reference angle here is going to be 225 minus 180 because I have 180 from here to here and 225 from here to here. So it means this part is going to be 225 minus 180, which is 45. That means I have a 45 degree angle, reference angle. Okay. Now, this is like a 45, 45, 90 triangle that we had before. So there's 45 as well. That was 1, 1, root 2. Now in this case, since I'm going to the left, this is a negative, and this is a negative here. So therefore, sine is opposite over hypotenuse is negative 1 over square root of 2. All right, tan of 315. Same thing, 315, here's 0, 90, 180, 270, 360. 315 is going to be in the middle like this. There's 315. This reference angle is going to be found by going 360 all the way around the circle minus 315 equals 45. And that means this is 45. This is 1, this is negative 1, this is root 2. Okay, tan is, so here's my reference angle, opposite over adjacent. And we get an answer of negative 1 like this. All right, guys, hope this helps. And so there's more examples in your notes, and there's a lot more examples in the textbook, guys. So I recommend that you guys get practiced up on this topic as well. Thanks.